So today we're going to continue our work with systems of elimination, systems of equations using elimination. Now remember, what we're looking for is where those two lines intersect. So we're bumping up that level of difficulty and doing a couple examples that are a little bit more difficult, plus a couple weird situations that we sometimes run into. So our example number 4 is the equations 3x plus 4y equals 10 and 2x plus 3y equals 7. Now remember, the goal, our very first thing that we need to do is we need to go ahead and make sure that either our x's are opposites of each other or our y's are opposite of each other. And you can see this is a little bit more difficult than the ones we worked on during our last class. And that's because there's not even a negative or a positive. So we have a couple options here. We can go ahead and make our x's a 6x and a negative 6x, or we can make our y's a 12y and a negative 12y. Now, the easiest way to go ahead and figure out what those numbers are that we want to turn them into is one of the simple techniques that you can simply multiply these two together. Make one positive, one negative. Now, it's not always going to be the smallest one that you could do, but you will always be able to find a solution where those two lines intersect using this method. So that's what we're going to go ahead and do. I'm going to go ahead and look at this, the x's, and I'm going to make the top one 6x and the bottom one negative 6x. So I need to go ahead and do what I learned last class, which is multiply every single thing on both sides by the number that will make that 6x. In that case, this is 2. So we have 2 times 3x is 6x, 2 times 4y is 8y, and 2 times 10 is 20. And I'm going to go ahead and multiply the one below by negative 3x. So once again, if I were to put these on Desmos, there are 3x plus 4y equals 10, and the one that I just did by multiplying everything on both sides by 2, 6x plus 8y equals 20, you would see that they are the same line, just simply on top of each other. We're not changing the line by doing this because we're doing the same thing to both sides. It's like changing a fraction of 1/2 to 3/6 by multiplying both the numerator and the denominator. So we've rewritten that top one. Now we're going to rewrite the bottom one. Negative 3 times 2x is negative 6x. Negative 3 times 3y is negative 9y. And negative 3 times 7 is negative 21. So last class, we just rewrote one of them to make them opposite. In this case, the reason why it's a little higher level difficulty is we need to rewrite both of them. So we're done with that second one. They're all rewritten, and now we're ready to simply add them together. So 6x and negative 6x cancel each other out. That's what we needed to do in order to start the system of elimination. 8y minus 9y is negative y, and 20 minus 21 is negative 1. Now we're going to go ahead and divide both sides by negative 1 to isolate our variable, and we get y is equal to positive 1. So we can go ahead and set up our answer and put our 1 in our y position. Now we're going to go ahead and we can plug that into any two, but we always plug it back into the original problem. So we're going to go ahead and use 2x plus 3y equals 7. No reason, you're going to get the same answer if you plug in to the top equation. So I'm going to go ahead and replace our y with what we know y now is, which is 1. So 2x plus 3 times 1 equals 7. 2x plus 3 equals 7. We're now going to subtract 3 from both sides. 2x is equal to 4. And complete isolating our variable by dividing both sides by 2. So we know that x is equal to 2. So we know that these two are going to intersect at the point 2, 1. Now we can check both these lines on Desmos, find where they cross, or we can use our simple substitution technique back into the original equation. So we have 6 plus 4 equals 10. That's true. And we have 2 plus 3. 2 times 2 is 4. 4 plus 3 equals 7. And yes, both of them do need to be true in order to know that you got the correct solution. Once again, this is the ordered pair where these two lines intersect. Let's go ahead and look at example 5. We have 2x plus 4y equals 10, and x plus 3y equals 8. So once again, we don't have a real simple, quick way to do it. We're going to have to multiply by one or both. So I can see making our top one 2x and our bottom one negative 2x. Those would be opposites. Or I can go ahead and do my y as a 12 and a negative 12. Once again, it's kind of just the way that you see it. You can do this a whole bunch of different ways as long as you're doing your calculations correctly and still get the correct answer. So I'm going to go ahead and multiply that bottom one by 2x by negative 2. That way I only have to multiply one of my sentences, one of my equations. So negative 2x plus 3y times negative 2 is negative 6y, and negative 2 times 18 is negative 16. So I've replaced that one. Now, for me, I like to write them right on top of each other because I'm going to add them together. So I'm just going to move that top equation underneath there. And now I have my opposites. So I'm ready to go ahead and add. Negative 2x and 2x cancel each other out. Negative 6y plus 4y is negative 2y, and negative 16 plus 10 is negative 6. We have negative 2y is equal to negative 6. So we're going to go ahead and finish solving for y by dividing both sides by negative 2. That gives us y is equal to 3. So I can set up my answer, once again, always in ordered pair, and I'm going to put a 3 in my y position. Now, once again, I'm going to go back up to my original orange equations here, and I'm going to go ahead and solve for x. Now, looking at the second equation, x plus 3y equals 8, x is already isolated, so that's a smart one to choose to save yourself some work. So I'm going to go ahead and substitute y for what we know y is, which is 3. So x plus 3 times 3 equals 8. X plus 9 equals 8. Subtract 9 from both sides, and x is equal to negative 1. So I can see that these two lines are going to cross at negative 1, 3. I can plug those in, and I have negative 2 plus 12 equals 10. That's true, checks out. And I can look at the equation below it. Negative 1 plus 9 equals 8. And yes, that's correct as well. So these are our kind of higher level thinking. We're doing the same thing we learned last class. These are just some more examples. Sometimes you have to multiply both of them, sometimes only one. Now, there's two weird situations here. Let's say you're going to go ahead and solve these, and you finish up and your variables go away, and you get something like negative 5 equals 7. This is not true. So you have to ask yourself, once your variables go away, is this a true statement? This is false. So negative 5 is not equal to 7. So because of that, we know that these two lines will never cross. They are indeed parallel lines. However, sometimes your variables fall away and you get something like 22 is equal to 22, and you ask yourself, is that a true statement? And of course that is true. Now, if that is true, that means that they cross everywhere, and that's because they are the same exact line written in two different forms. So in this case, it is the same line. So be aware as you're solving systems of equations, these two things could happen. You could be looking at a pair of lines that never intersect, which means they're parallel, and you could be looking at a pair of lines so they're actually the same line on top of each other, and so they intersect everywhere. So that's just kind of what you need to know as you're solving for these problems. Let's go ahead and practice.